Traditionally, what has been used to repair nerves that have been cut or lacerated, if the gap hasn't been too large, surgeons can use direct repair where they just suture the nerve ends together. But it's very easy to put a lot of tension on that repair. And that can have a lot of detrimental effects on regeneration. And it's also very easy to misalign the fascicles, which again can cause misaligned axon growth, and then you can end up with neuroma formation. Then for larger gaps where maybe the nerve ends couldn't be brought back together, there were hollow tube conduits. But these really are limited to use in small gaps because they work on the basis of formation of a fibrin clot within the conduit. And that fibrin clot acts as the substrate that the axons use to make their way across the gap. But the issue with that fibrin clot or fibrin cable is that at larger gap lengths, the mechanics of that fibrin cable cause it to collapse down in the middle. And when it collapses down in the middle, it only provides a very small cross-sectional area where axons can cross. And so you get fewer and fewer axons that are able to cross that gap. And eventually you get to a gap length at which that fibrin cable will fail to form at all, and you won't have any regeneration across that gap. And then finally, for larger gaps, the traditional method has been autograft. And so, autograft, lots of surgeons see this as the historical standard or the gold standard. But, it does cause a deficit in the area of the body from which you are removing the nerve. In addition to that functional loss, you can have neuroma formation at that nerve. So you can end up with things like pain, and then you have the inconvenience of having a second surgical site and the potential for things like infection and other comorbidities that can go along with having that second surgical site. So, the reason why surgeons have really used this in the past is because they see it as being advantageous because it does come from the patient and does contain those Schwann cells. And so surgeons really like the idea of having those Schwann cells in there to aid in regeneration right away. But again, this is really not it's not as advantageous as some surgeons might think because there are a lot of downsides to it. You are creating a new injury. The complication rate has been reported to be as high as 22%. And those complications are things like painful neuromas and hyperesthesias, which can be really bothersome for the patient. It also can add OR time. And there's only a finite amount. So, once you've harvested both sural nerves, that's pretty much all you have. And so it may not be enough to adequately perform the repair. It can also be inconsistent quality. Sometimes sural nerves can be really thin, really ribbony. So it may not be really the optimal nerve to use for the repair. And typically it's smaller in diameter than the nerve that the surgeon is trying to repair. So they have to use multiple cables of that graft in order to match the diameter of the nerve.